So for this example, we've got this plane x plus equals 1 and this cylinder x squared plus y squared equals 1, and what we're trying to find is their intersection. From first sight, we can say that this intersection is a curve because we've got two equations and three variables, so an infinite number of solutions. So it's not a point, it is gonna be either a curve or they're not gonna intersect at all. Okay, let us try to verify this graphically. We don't need to graph in 3 dimensions, we'll just graph on the xz plane. Okay, we're dealing with a cylinder and a plane, so it's okay. On the xz plane, we know that y equals 0, so if I plug y equals 0 right here, what I'm gonna get is x equals -1 and x equals +1. And here this is just gonna be graphed like this, so I have 1 right here and 1 right here, so I'm just gonna draw this line, and from this I can tell that this curve of intersection is gonna be an ellipse. Okay, so it is gonna be an ellipse because these two lines, they somehow represent our cylinder. Okay, and this line represents our plane, so we have this plane piercing through the cylinder, so it will give out an ellipse. Okay, so let us just try to get into the action. I'm gonna start by assuming a free variable. I can go with x, y, or z. I know this is an ellipse. Okay, so what I can do is assume maybe x as cosine or just sine phi. Okay, I can do this. It will make stuff easier because when you're expressing an ellipse or a circle, using trigonometric functions is going to make it easier. Okay, so I will still just go with my own z equals t. Okay, z equals t, this means that x equals 1 minus t. Now I'm gonna find y in terms of t, so y squared equals 1 minus 1 minus t squared, so y equals, okay, just adding equal, y equals positive or negative the square root of 1 minus 1 minus t squared, and my vector function which expresses this ellipse is gonna be 1 minus t plus or minus square root of 1 minus 1 minus t squared and t. Okay, now we can see that this thing is a problem right here. I mean, you'll not be happy dealing with this in your integrals, so what we can do is think of what can we do to make this simpler. Okay, and what I'm gonna do is substitute 1 minus t with sine theta or just sine phi, and in this case this whole term is gonna be cosine phi. This is just gonna be sine phi, and this is gonna be 1 minus sine phi. So yeah, both of these express all points on the ellipse, except that this one is much easier to deal with, maybe in your integrals. So that's why it would be better if it wouldn't be much of a change anyway. If you start by assuming x equals cosine phi or sine phi, you will still reach something like this, which expresses all points on the ellipse. But I prefer going like this and then asking myself about what substitution can make this vector function look better. Okay, so yeah, that's the video. I hope you enjoyed it, and thank you so much.